Hello, my name is Xander Chambers. Today I'll be presenting my CSE 120 Intro to Programming with Python final project. My project was the Vehicle Mileage and Maintenance Tracker. My project sets out to solve a problem. Firstly, fleets are hard to track. When you own several vehicles yourself, or you may be the head of a family that has several vehicles. In my case, this is the reason that I essentially set out to solve the problem in the first place. Uh, my family owns several vehicles, just like any family, and all of them are old vehicles. They all require a great deal of maintenance, and they're frequently down. And these older vehicles in particular frequently have no built-in reminder systems for regularly scheduled maintenance, or they'll throw codes that require specialty tooling like code readers just to reset those once you have actually completed the maintenance. And obviously, I don't even need to say it, but missing one of these service windows can be critical. In the event of a tire that needs to be replaced, if not replaced adequately or on time, the tire could blow out and it could cause an accident. Your family member could die on the freeway, and nobody wants that. Uh, in the case of engine oil, it could seize your engine with coolant. It could seize your engine. These are all things that could total a vehicle and put you in significant financial hardship. For as significant and as catastrophic as some of these problems can wind up being, the solution needs to be equally rigid, significant, and preventative by its design. So initially, the first thing that's important is that the program is persistent, and you can carry data from one session to another. In the event of vehicle maintenance, you very rarely, if ever, will perform a maintenance task and then need to perform that same maintenance task within a single session of a Python program. You will want to be able to carry this over a period of months and thousands of miles for an entire fleet of vehicles, which brings us to the next point. The solution, this Python program, needs to have all of the vehicles available at all times. You should always be able to see all of them, and it should never be a question of whether or not one vehicle in your fleet is falling behind and due a service, but you're unaware of it. So to achieve that, the menu-driven interface keeps it simple and uh, without any form of complexity that could confuse a user, even one that isn't super technically inclined, like my grandfather. So, for all this to be possible, the program is built using these four building blocks. The first of which, as I mentioned before, is data persistence. Uh, the program needs to have the ability to carry session data from one day to the next to ensure that the mileage for a vehicle is never questioned. It is always accurate and up to date. Secondly, is fleet management. Not only do you need to be able to add vehicles, but you need to be able to update the mileage for each of those at any time, regardless of whether or not you have logged a service. Obviously, we drive vehicles every day, and you're going to want to update the mileage anytime that you do. Additionally, a family member may get a new vehicle, or a family member may sell an old one. You need to be able to manage all of this. Also important is logging the services to start with. You can record the service history and any of the services that take place for any of the vehicles, as well as do custom intervals depending on the kind of vehicle that you have. All of these things work together in conjunction to then alert the user for the entire fleet and for every service as to whether or not the vehicle needs that service or if it has no history. Now, from a technical perspective, the most important thing, the beginning of the program, is the JSON file. So we use save and load data. First, we use load data to check and see if there is an existing file for the fleet that is an existing JSON file. If there is one, which if this is not the first usage of the program, then there will always be one anytime that data is recorded. But if not, then it will create a JSON file to save the fleet data. Save data is used many times throughout the program. Anytime that any part of the fleet data is changed, say you add a new vehicle, you change the mileage on one, you change the service history for a vehicle, save data needs to be used to update that JSON file and make sure that it's correct for the next session. Together, these two functions are what let the tracker remember every vehicle and its data after the program closes and is opened later. Next, we'll talk about managing the fleet. So each vehicle in the program, in this file, is added and stored under a unique nickname, which is the key for the dictionary used for every lookup in the future and for every update. Adding a vehicle, you would add, say, in my case, I added a nickname Sport Bike, and I recorded its make, which is BMW, its model K1200R, and mileage, it's 26,000 roughly. And then it will allow you to fill out a default set of those maintenance intervals. Mileage updates are also validated. The new reading must be numeric and cannot be lower than what's on file. Obviously, the mileage of a vehicle is not going to decrease from what it was, so these error codes are important. Obviously, the mileage cannot be not a number, so using these try and accept formatting, we can further increase the usability of the program and reduce the number of errors that might occur. Next, I'll talk a little bit about logging service intervals as well as custom intervals in this program, which is actually one of my favorite parts about the program, is this flexibility. So obviously in logging service intervals to start with, that is generally the purpose of the program as a whole. Every completed service is appended to the vehicle's history, so you can see not only the last time that the vehicle was serviced for an oil change, but the entire history of that vehicle's oil changes, allowing you to see the intervals, whether they were late or not. But for me in particular, having a lot of vehicles that are not incredibly similar, like with oil changes on vehicles, cars, for example, typically, and the newer ones go quite a bit longer without oil changes, and they use full synthetic. And all of this is different from a motorcycle. So owning both cars, diesel trucks, motorcycles, other non-standard vehicles in your fleet with the standard vehicles means that the service intervals for them are not the same. Motorcycles need their oil and their tires change sooner than cars, and vice versa. So being able to do this allows the program to be even more flexible than it would have been. A good quality of life improvement as well is the ability for the mileage to always remain in sync. You don't have to log a service at such and such miles. Say that initially the vehicle had been set at 25,000 miles on the odometer. Anytime that you complete an oil change after that, say at 35,000 miles, the system will automatically update that mileage number to the current mileage for the vehicle. You don't need to do that separately. It's one less thing for the user to enter twice. Well, likely the most critical part of the entire program is the maintenance alert system. Without this, you would just be tracking all of these things, and it would never tell you when the time for a particular service is actually due. The program itself loops through every vehicle in the fleet, no matter how many you have, and every service that particular vehicle tracks, as several vehicles may not always track the same services. You may have additional things like cam chain adjustments for older motorcycles in particular, whereas newer ones may have oil reservoir style systems that never need maintained. It then finds each service's most recent occurrence in that history, calculates the miles that were elapsed since that service, compares it to the interval that you have recorded inside of the program, and then it tells the user whether it's overdue for that service, whether it's safe, or it's never even been recorded inside of the program. As I mentioned before, a big part of the reason that I created this particular program at all is for my family and my very much technologically not inclined grandfather. So at the bottom of the program, I built this menu, which is incredibly easy to navigate. I think that even he could. This menu ties all of these features together, so you never need to remember any type of function name or command and type anything specific. It's all very user friendly, and you can always return to the menu after you've done a thing, whether it be add a new vehicle, log a service, or update the mileage for vehicles. So the program was put together in roughly 5 weeks, using first to set up the dictionaries and the menu, which felt like the easiest place to start. Second, which is the thing that I didn't know at the time, I needed to research the methods for storing and retrieving the data across sessions, which is when I learned about the JSON files. In week 3, I looked at the storage methods against those written menus and dictionaries that I had already implemented, which is, once again, where I decided that the JSON file would be the best. In week 4, I played with the program a little bit. I added some different vehicles, made sure that the menu worked properly and I couldn't generate any errors, populated that JSON file, and continued to work with it through week 5, producing my report in that week. Notably, I learned some things and also faced some challenges throughout this process. I guess in particular, the most important thing that I learned, which was something that I'd never heard of up until I started working on this project, is the JSON module. I had no clue that there was any way to store data across sessions with Python, and learning that in itself, as well as how to actually do that myself, I thought was extremely valuable. Also, working and designing these nested data structures, these JSON files contain these dictionaries, which contain lists, further dictionaries to keep all of this stuff organized and easily retrievable. That was also the biggest challenge that I faced, getting these nested data structures to work properly, and syntax-wise especially, getting everything to work properly was a huge challenge for me.